All right, so just continuing along our merry way, we have another integral, indefinite integral of x over the square root of 5 minus x squared dx. So I'm going to go ahead and change this radical to a 1/2 power, and then I'm going to bring it up top with a negative 1/2 power. So this is now the integral of x, 5 minus x squared to the negative 1/2 dx. So what is your u? It is 5 minus x squared. What is your du? It is a negative 2x dx. So again, what am I missing? I need a negative 2 here. So how do I balance? I need a negative 1/2 out front. Okay, so that gives me negative 1/2 times negative 2 is 1. I'm not changing what it is. I'm changing what it looks like. So now I'm going to carry my negative 1/2 as a constant multiple out front. This is going to be rewritten as u to the negative 1/2. And then this is my du. And when I integrate, negative 1/2 is coming along for the ride. U to the negative 1/2 becomes u to the positive 1/2 divided by 1/2 is times 2 plus c. So that reduces out except for the negative. So I have a negative u to the 1/2 plus c. But I started it in x world, so you better end in x world. So not every time, again, just because we're learning this does not mean you have to undo the chain rule. It doesn't mean you have to balance. So I've got the integral of 2x squared plus 1 over 2x squared dx. Well, that squared is easily distributed. Okay, so I can rewrite him as 2x squared plus, remember that's the same thing as 1 over 2x times 2x. So that's actually 1 over 4x squared. And now all I got to do is bring that up top with a negative exponent. So I've got a 2x squared plus 1/4 x to the negative 2 dx. And now I can integrate, and I don't even have to balance anything. So 2x squared becomes 2x to the 3rd over 3. And this becomes x to the negative 1 over negative 1, which is a negative 1/4 x to the negative 1 plus c. Okay, so you don't have to do this just because we're learning it. So now I have the integral of 7 sine of 7x dx. So what's your u? Your u is going to be the argument of the trig function, because that's the inside, and I don't have, or its derivative is not 1. So my u is 7x, my du is 7dx, and I don't have to balance anything because I've got what I need all right there. So this is now going to be rewritten as the sine of u du, and if I integrate sine, I get a negative cosine. So negative cosine u plus c, and then just back substitute. So negative cosine 7x plus c. Another one, I'm trying to get to where we can use some fun u substitution. You're like, what? All right, anyway, we have the integral of cosine 9x dx. So my u is the inside. He's a 9x. My du is a 9 dx. So I am missing a 9. I'm going to balance with a 1/9. Because again, if I multiply those, I just get 1. I haven't changed anything. I've just changed what it looks like. So now when I repackage this, I get 1/9 times the cosine of u du. Here's your du, and there's your u. And the integral of cosine is sine. So 1/9 sine u plus c, which will become 1/9 the sine of 9x plus c. Oh no, I'm out of paper. All right, a couple more. And then I'm going to do a separate video on changing the limits of integration. Because it's actually, it sounds scary, but it's fun. All right, so I've got the integral, hang on, of the 7th root of the tangent of 8x times secant squared 8x dx. So you've got some multiple insides. I've got the inside of 8x whose derivative is 8. Well, I have a whole heifer lot more than just an 8 out here, so I better start concentrating on the trig functions. If you'll remember, the derivative of tangent is secant squared. So my u is going to be the tangent of 8x, and then what's your du? It's going to be secant squared 8x dx times the derivative of the inside, which is 8. Okay, so I've got my u right here, and I've got almost all of my du. I'm missing an 8. So I need to multiply by 8 and balance with a 1/8. So he's coming along for the ride. He's going to get sucked into my du. He's still there. I'm just too lazy to write it. So I've got a 1/8 times the integral of u to the 1/7. Okay, this tangent function is raised to the first, but I'm taking a 7th root. And then the rest of this is du. Okay, so this is a whole lot prettier than what we thought it was going to be. And I know how to integrate this. So the integral of u to the 1/7, carry along your 1/8 for the ride. And then u to the 1/7 is going to become u to the 8/7 divided by 8/7 is times 7/8. So my lead multiple is now 1/64 of this thing to the 8/7 plus c. Well, what's your u? Your u is tangent 8x. Okay, so make sure you put tangent completely in parentheses, or write that as 1/64 tangent 8/7 8x plus c. If you don't have that exterior set of parentheses, you're going to be raising 8x to the 8/7 instead of the tangent function. So either way is fine. One more, and then we'll flip out. So I have an initial condition. Okay, so my problem is I have f prime of x equals a negative 2x times the square root of 8 minus x squared, and I know it travels through the point 2, 7. Okay, so remember, this is my initial condition. If you're given an initial condition, it means that you're going to resolve your plus c. So I'm going to integrate both sides. And so the integral of a derivative is the original function. And now, well, what's your u? My u is an 8 minus x squared. So my du is a negative 2x dx. So there's my u, there's my du. I don't need to balance anything. So this becomes the integral of u to the 1/2 du, and that 1/2 is coming from the square root. Okay, so the entire argument is raised to the first power, and I'm taking a square root. So now I can integrate. So the integral is going to be u to the 3/2 times 2/3. So 2/3 u to the 3/2 plus c. But I'm in terms of x, so fix it. So I end up with f of x equals 2/3 times 8 minus x squared to the 3/2 plus c. So now I can resolve my plus c. Okay, I know that if I shove in an x, I'm going to get a y. So this is my y, so 7 equals 2/3 8 minus 2 times 2 is 4 to the 3/2 plus c. So 8 minus 4 is 4. And then the square root of 4 is 2 to the 3rd is 8. Okay, so 4 to the 3/2 is 8. So 7 equals 2 times 8 is 16/3 plus c. And now I'm going to subtract 16 thirds. So 21 thirds minus 16 thirds is going to be 5 thirds. So 5 thirds is your value for c. So up here, that is no longer a plus c. You've just figured out that that is a plus 5 thirds. Okay, so let me see if there's something else exciting I can do at the end of this thing. Let's do the last one. And then I'll just have a short video for the u substitution. Oh no! I'm out of paper. Hang on. We're just going to go up here. All right. So the last problem on this says, by the way, what you've been doing with the limits of integration when you've been evaluating is called the fundamental theorem of calculus. All right. So what we want to do is use the fact that from 0 to 3 of x squared dx is 9 to evaluate each of the following problems. So I'm going to write this out. Well, remember that an x squared is just a parabola that looks like this. And then if I'm evaluating from 0 to 3, that means that this part is from 0 to 3, and the area of this shaded in portion is 9. Okay, so the first part says I'm going to go from -3 to 3, okay, of x squared dx. Well, all that means is that I'm going to come over to here as well. So if I'm going to integrate from here all the way over, well, by symmetry, you're just going to double this. Okay, so this part's 9. That means this part must be 9. So this must be 18. So what happens if I go from -3 to 0 of x squared dx? That means I just want from here to here. Well, by symmetry, if this is 9, this is 9. So that just must be 9. By the way, if you do integrate all this stuff, you're going to get the same answer. What if I go from 0 to 3 of -4x squared dx? Well, remember, you can bring your -4 out front. So if this is x squared dx, I already know that this portion, stop it, is 9. So that red box equals 9, which means I'm at a -4 times 9 is a -36, which should make sense. That -4 is going to flip it over, so it makes your area negative, and then you stretch it by a factor of 4. And then your last one is going to be from -3 to 3 of 5x squared. So from -3 to 3 of 5x squared dx, well, again, I'm going to bring my 5 out front. So going from -3 to 3 of x squared dx, I figured out on step 1 that this portion is equal to 18. So if I just take that and say 5 times 18, that's going to end up giving me 90. So that's your answer on that one. And so the last video is only going to be 4 problems, but it's u substitution with limits of integration.